Let's take a minute to clean up our definition before we go to work trimming our ceiling tiles down a little bit. So I'm just going to pull some of these elements back and just kind of neaten them up. This gives me a little time to actually think about what I'm doing at the same time and take a look at the code, find out what I put in that's needed and not needed. Like for instance, we no longer need the watch box. So what I'll do is I'll just connect the height of these directly to there, and I'll just push this off to the side for a minute. And now we're ready to look at trying to shrink this whole thing down a little bit so that it fits in the definition better, or fits in the, the length of them fits what a ceiling would be better. So let me just zoom in here, and we know that the length of these at the most is 20, and they scan down to 25. So if we could take most of the 20 out, we'd come with a nice, almost trim set of ceiling tiles, if that's what they're going to be. So let's look at doing some math to that, just some addition and subtraction, and I'm going to use a code block to do that. So I'm going to type in code block, and I'm going to type in x just so it's a variable, and I'm going to minus 19.5. I don't want to take away 20, because if I do, and if I click off of that, it'll automatically give me an x for an input, and it'll give me an output. So I can now take that curve length, put it in for x, and I'll plug it in the watch box so you can see what's going on. Now if we zoom in here, you can see that where it was 20 at 0.5, it's at 5, it's now 0.5. So it's 20 minus 19.5. So all of these numbers have been shrunk down to basically what their minimum could be and still have variation with each other. So let's feed that in as our height. And there we go. Now we've trimmed them all down. Our only other problem is they're going in the wrong direction. Let's see if we can fix that. I'm going to put a negative in front of this. And they're still going in the same direction even though the values have turned negative. So our cuboid by length function isn't going to serve us very well to accomplish this task. So I'm going to go through a couple of different ways to do this. And one of them is to actually just substitute out cuboids now for cylinders, because I know that cylinder by radius and height will work, because if I put a negative value in for that, it will give me what I want. So I'm going to select one of those. You'll notice that once I brought it onto the screen, I get a cylinder, but I need a coordinate system, because if I feed the origin into it, it's going to reject it. Even though those are defined as points, there's no, it's not defined well enough for this function to actually work. So we need to transfer the idea of these points into what is a unique coordinate system for each point. So let's search for something that will allow us to do that. So I'm just going to type in point, and coordinate system. Doesn't like it that way. Let's try CS. Oops. And point. Still not giving us anything nice there. So let's see. So I had a hard time finding this function. So I went over here and searched for, put in point, and I come up with point by origin, which is this point will give us a coordinate system. If I click on this, bring it onto the screen, and I feed our points in as the origin, what will happen is we get these little coordinate systems for each one of those. That's CS, which is something that this function is really happy to get. And there we have all of our cylinders now. Radius of 1, height of 1. And we want to change our radiuses, so we're going to change the height. And because I have this negative, you'll notice now they're going down in a negative direction. And we can take a look at this. Rotate down, and now we have a ceiling plane that's sculptural according to that NURBS surface. So Next, I'd like to take this and bring it into Revit. We'll do that in the next clip. Let me show you where we're at here. On this, we have our objects ghosted in from Revit, and we want to actually make these real objects. So we'll do that in the next clip.